Welcome, Algebra 1 students, to topic 6D, solving quadratics by factoring. All right, so last week we learned how to solve quadratics by square roots. Today we're going to continue our solving quadratics, which is really finding the x-intercepts. We say finding the solutions, finding the roots, finding the zeros, all different ways that we say for solving quadratics. This week we're doing it by factoring. So our essential question this week says, or today says, how does solving for x in quadratic functions compare to solving for x in linear functions? You could have answered this question last week as well, right? We're solving for x in both when we're looking for x-intercepts, but how we go about doing that is a little bit different if it is a quadratic. And so last week we learned square roots, this week we're going to learn factoring. So now let's solve by factoring. If, it says big if here, let me change my pen color, hold on. All right, so let me make this a little bigger so we can fill in the blanks here. All right, so if, I'm gonna box this if, right? If a quadratic is factorable, that's what we learned how to do in Unit 5, we can solve the quadratic by factoring. This only works if the quadratic is not prime. So if you remember last unit, we were factoring, and then if we could not factor it, we said that it was prime. All of those prime quadratics can be solved. They're just going to have to be solved using the method that we will do in our next set of notes. So, but this method works for factored problems, which is last week's method of square roots. If the problems do not have a bx term, or they're set up in vertex form, have those parentheses with the squared thing on them already, then the fastest way to solve those is to take the square roots like we were doing last week. If problems then are ax squared plus bx plus c, and the fastest way to solve them, if they're factorable, is to factor them. And then the third method works for every single quadratic that we will learn next week, or next set of notes. Excuse me, my allergies are flaring up. So it says to do this, we will need to use the zero product property. And this says that, let me scroll over here, for every real number a and b, if, excuse me, if a times b equals 0, so what we're saying is that if a times b equals 0, then either a equals 0 or b equals 0. So this is what the zero product property tells us, and this is the property we're going to use to be able to solve quadratics by factoring. So the other key thing we need to remember that is, as we learned in our last topic, 6C, to solve for x-intercepts, right? These are x-intercepts. So if the problem has a y, then we have to make sure we set the y equal to 0. The whole goal here is to find the x-intercepts. For every x-intercept, y equals 0. This is why this property works. So let's take a look at number 1 here. So number 1 here is already factored. So this would be a problem, like if we were factoring it, we already have it factored here. So it says x plus 3 times 2x minus 1 equals y. So really the first thing we need to do is the zero product property. I mean, not zero product property. First we need to set the y equal to 0, right? So we have x plus 3 times 2x minus 1 equals 0. And then because of the zero product property, right, we have, this is really a, this whole x plus 3 is a, times this whole 2x minus 1 really is b, equals 0 is what we start with the zero product property. And then what that says is that we are going to take, that says that either a equals 0 or b equals 0. So let's do the a equals 0 first. So we have x plus 3 equals 0. And then we solve for x, right? Subtract 3 from both sides. X equals negative 3. That's the A. And then we do the B. So the B side says 2x minus 1 equals 0. So then we solve for x, right? I'm going to add 1 to both sides. So I have 2x equals 1. Divide by 2, divide by 2. X equals 1/2. Right, so this is my answer. Negative 3 comma 1/2 is what x is. We're solving for x. Remember, just as a note here, I'm going to write it again for just for reminder, that if we're asked to find x-intercepts, or if we're asked to solve for x, this is the answer. If we're asked to find x-intercepts, so I'm going to put that if looking for x-intercepts, right, then the answer would be -3, 0, and 1/2, 0, right? If they were x-intercepts, we would list them as points with the zeros for the y, because we set the y here equal to 0 there. But for our what we're doing now, solving and we're writing it with x equals is good enough. Right? So this is solving by factoring without having to actually do the factoring step. So the first 2 or 3 problems here, I didn't actually make us do the factoring. I'm just having us use the zero product property. So I'm going to scoot over to number 2 here. There we are. All right. So here we are. This is already factored, right? So first thing we do is rewrite it with x equals or y equal to 0. So 2x times 3x plus 8 equals 0, right? This is already factored form. Factor 1 is 2x, factor 2 is 3x plus 8, right? So now we do the a times b, right? This is a, this is the times b. So we're going to set the a equal to 0, and we're going to solve for x. So 2x equals 0, divide both sides by 2, x equals 0. And then we have to do the b. 3x plus 8 equals 0. So subtract 8 and subtract 8 from both sides. So 3x equals -8. Divide both sides by 3. X equals -8/3. So my answer is x equals -8/3, 0. Right? So it's already factored. Then all we have to do is set our each factor equal to 0 and then solve for x for both sides. Right? Most of the time we're going to have 2 x's, not all the time, but a lot of the time we're going to have 2 x's, because remember, quadratics can have 2 solutions, 1 solution, or 0 solutions. All right, let's go back over now here to 3. 3 is also already factored, so I'm going to go ahead and rewrite it with y equal to 0. So we have 3 times x minus 4 times 3x plus 7 equals 0. Now this 3 out front is like a GCF, right? Sometimes we're factoring GCFs out of our quadratics first. So that would be like a GCF we factored out front. Now, I'm going to show you why in reality we kind of get to just ignore the GCF out front, because I can get rid of the GCF out front right now if I took and divided this entire side by 3 and then this side by 3, right? What we do on the left, we can do on the right. If I do that, these two 3's divide out, right? They simplify out and become 1, and we're left with x minus 4 times 3x plus 7 equals 0 divided by 3 is 0. So by dividing out the GCF first out front, as long as that GCF does not have a variable in it, if it had a letter in it, then this would not be a quadratic anymore, because it'd be 3 x's, right? Quadratics only have 2 x's. So since that 3 is out front, it's a number, we divide it out of every term, or out of both sides, right? Because this is one big term, because it's all multiplication. We divide out both sides, it kind of just goes away. So I don't even usually take the time to divide out that 3. I recognize we don't really care. We take it out when we factor because it makes the math easier to do the solving. But at the end, when we're actually doing finding our answers, doesn't matter. We can just kind of ignore it, because now we're set up to solve for our 2 x's, right? We have x minus 4 equals 0, which we add 4 to both sides. So that's x equals 4. And then I have 3x plus 7 equals 0, right? So we're going to subtract 7 from both sides. So this is 3x equals -7. Divide both sides by 3. X equals -7/3. So my answer is x equals -7/3, 4. Right, so there we are. So really, we got to kind of just ignore that 3 hanging out front. You could divide it out of both sides first and then keep going, but that sometimes also happens. So I wanted to show you all three of those kind of problems before we actually start factoring to solve. So this next problem, now we need a factor to solve. So let's go over here. Here's a quadratic, right? X to the power of 2. First thing we do is set that y equal to 0. So I have 3x squared plus 6x equals 0. Now on the left-hand side, we're going to kind of ignore the equals 0 part. And on the left-hand side, we're going to factor. Our first rule of factoring is there a GCF? So I look at this and I say I could take out a 3x out of both of these terms. So if you can divide a 3x out of both terms, and I end up with 3x out front. And then that's x plus 6 divided by 3 is 2, x divided by x is 1, then this whole thing equal to 0, right? So we divide out a 3x GCF, I can't say that, and then divide out of both sides. Now we have a factored problem, right? It's already factored, so now we can just solve it, right? I'm going to take this 3x and set it equal to 0, divide both sides by 3, x equals 0. And then I'm going to take the x plus 2 equals 0. Subtract 2 from both sides. X equals negative 2. So my answer is x equals negative 2, comma 0. As I told you before last week, I don't care which order you put them in. Typically, mathematicians will put things from least to greatest. On the test, you may be asked to write it from least to greatest. I think you were in the last test. So it might be a good habit to get into, or make sure you read directions if you're doing problems on a test. But there we are. Negative 2, comma 0. So here, I'm going to make a note up here because we forgot this all the time, right? That if we can, when we're factoring, we should always first factor out a GCF if there is one, right? So I'm going to make that a note first here. Just a factor reminder from Unit 5, right? In Unit 5, we learned that we're going to first take the GCFs out, and then we can solve. All right, now let's look at number 5. Rolling right along. Here we go. So we have a quadratic. First thing is to make that y 0. So I have negative x squared plus 8x equals 0. And then next I'm going to take out a GCF if I can. So I look and say, anytime there's a negative sign out front, I am typically going to take that out as part of you should take that out as part of your GCF. And there's also an x in both of these. There's no c term here. So I can divide out a negative 1x from both of these. So I have negative 1x out front, and that leaves me with 1x, and 8 divided by negative 1 is negative 8. You don't have to put that 1 in front of that x, but you can, right? There's no number in front of an x, it's a 1. If there's a negative sign and no number, it's a negative 1. Now we can go ahead and solve, right? So negative 1x equals 0. Divide both sides by negative 1. X equals 0 is one of my factors. And then 1x minus 8 equals 0. Add 8 to both sides. X equals 8. So my answer is x equals 0, comma 8. There we are. If you noticed, every time we did not have a c term, then one of my x's was 0, right? Because we were able to take out a GCF that included the x that got us right there. So anytime you do not have a c term in a problem, one of your x's is going to be is going to be 0. You're going to be going through the origin, right? 0, 0 is the origin. All right, number 6, last one on this page, and then we'll do a couple more on the other page. All right, so this one, kind of like when we were doing square roots, does not have a y. This is a quadratic problem where we already kind of put the 0 in for y. It's kind of shown in a different way. So it's important that that we need to make sure it's in standard form, right? Standard form ax squared plus bx plus c, and equal to 0. Right? This is important. We got to make sure we do this first, right? Before we even do a GCF, technically, when we're solving, we got to make sure it's in standard form. Very similar like yesterday before we could do the square, or last week before we could do the square roots, we had to make sure that the square term was by itself. We had to isolate it. So this is this, when we're doing it from standard form, it has to be in standard form. So first thing I'm going to do is subtract the 9x from both sides. All right, so we have 3x squared minus 9x equals 0. So we have equals to 0. You cannot do this until we're equal 0. Equal 0 is super, super important here. Has to be equal to 0. The rest of it should be in standard form. And so now I look at this and say, okay, I got a GCF. I'm going to take out a 3x from both of these. So I have 3x on the outside. I have 1x on the first term. Negative 9 divided by 3 is negative 3 equals 0. And then now, let me switch to red again. Here we go. 3x equals 0, divide by 3, x equals 0. And then we have x minus 3 equals 0, add 3 to both sides, x equals 3. So my answer is x equals 0, comma 3. All right, so if it's not in equal to 0, get all the terms, move all the terms over so they're all on one side. Does not matter which side you put them on, as long as they're all on one side together. And then make sure that when you put them together that they're in standard form. All right, I'm going to go to the next page now. We got a few more problems to do. Here we are. So these ones are, we only have 3 more to do because these ones are a little bit longer. So factoring, so if you remember, the easiest factoring to do is when you just had a GCF. And then sometimes we had to do more than just a GCF. So I'm going to make this nice and big. Hopefully we have enough room here. I guess we'll find out. Make sure my blue pen. Here we go. So first thing we do is set this equal to 0. So I have 0 equals x squared plus 6x plus 8. Now this part here on the right is what we're going to factor. Now this one, the GCF, the only GCF I see is a 1. So we don't need to do the GCF step. It is a quadratic trinomial in standard form. That means that we need to do quadratic trinomial factoring. So we need to box that 6. We need to grab the 1 that's out front and the 8. So that makes that a positive 8. 1 times 8 is 8. 8 times 8a times c, right? The first term times the last term, what we're doing to multiply, because we need to figure out how to split that 6x. So positive 8, my factors of 8 are 1 and 8, and 2 and 4. Because it's positive, we need to have the same sign, so we're adding, and we need to add to 6x. So 2 plus 4 is 6x. They're both going to be positive because this is a positive 6x. So I'm going to go over here and write x plus 2. Oh, what am I doing? Ooh, let's try this again, Mrs. Kim. I'm not going to do the shortcut. I'll do the whole thing. So, right, so we're going to write x squared, and then we're going to write plus 2x, and then we're going to write plus 4x, and then plus 8. And then I'm going to draw my wall, take the GCF out of the first 2, which is a 1x from the first guys. So I have x times x plus 2. GCF out of the second 2 is a 4. So 4 times x plus 2, right? These two things should be exactly the same. They are. So we have x plus 2 times our other GCFs out front, x plus 4. This whole thing is equal to 0, right? We're supposed to be equal to 0. That equal to 0 is still here, just hanging out until we're done. Now, you could have recognized since the a term was 1, we could have gone from here directly to there and skipped that part in the middle. So we could have skipped the middle part because this ax squared term up here is 1. If you remember that, great. If you don't remember that, then just factor it. You'll get to there. But now that we've factored it, we're not done, right? We're solving for x as this unit. So now I need to take and get the x plus 2 equal to 0 and find this x. So here's my first x. X equals negative 2. And then I'm going to do the x plus 4 equal to 0. Subtract 4 from both sides. X equals negative 4. So my answer is x equals negative 4 and negative 2. All right, so we're combining what we learned in Unit 5 with what we're learning now to solve. So if it's a quadratic trinomial, we need to do the quadratic trinomial factoring in order to solve it, or to factor it, and then once we factor it, we can continue to solve it, because we need to find the values of x. All right, we got two more. Come on up, here we go. So let's set this equal to 0 first. So I have 3x squared minus 11x plus 10 equals 0. Doesn't matter if the zero's on the right or left. All right, we're going to quadratic trinomial factor, right? Because 3, 11, 10 don't have any GCF, so I'm just going to start factoring. Box that middle term. Multiply the 3 times the 10, which is a positive 30. So we're going to use positive 30 to split this a negative 11x. This one's going to require the split because it's a 3x squared. Whoa, I forgot the x squared on there. Let's put that on there so it's correct, right? Because it's a 3a value for the x squared term, we're going to have to do the whole thing for sure. All right, so let's do my factor pairs. 1 times 30, 2 times 15, 3 times 10, 4 does not go in, and 5 times 6. It is positive, so that means we're adding, and this time we're going to add to negative 11x. That means both of them are going to be negative. So 5 plus 6 down here is a negative, so it's a negative 5 and a negative 6. So I have there we go. So we got 3x squared minus 5x minus 6x plus 10. You can keep writing the equals 0 if you want, right? Then we're going to draw our wall down here, and then we're going to take out our GCF. So 3x squared and negative 5x, the only GCF is a 1x, or just x, your choice. So x comes out. It's 3x minus 5 inside. On this side, it's the x term has a negative, so make sure we take that negative out. 6 and 10 have 2 in common, so we're going to divide out a negative 2. So this negative 6 divided by negative 2 is 3 times x. 10 divided by negative 2 is negative 5. Right, so now these two things in parentheses are the same. That's what we're looking for. So 3x minus 5 times x minus 2 equals 0. Right, so now that I've factored it, I can solve for x's. So 3x minus 5 equals 0. Add 5 to both sides. 3x equals 5. Divide by 3. X equals 5 over 3. And then we're going to do the same thing with the x minus 2. So I have x minus 2 equals 0. Add 2 to both sides. X equals 2. So my answer is 5 over 3, comma 2. Right, so gotta use all that quadratic trinomial factoring. Quadratic trinomial factoring is faster than tomorrow's lesson where we learn the quadratic formula. So if you can factor it and you get good at the factoring, especially number 7, right? Number 7 is super easy because there's a 1 coefficient for a. So those are the super easiest ones to factor. Number 8 is not too bad to factor. It takes a little bit of work and effort. All right, one last factoring problem. Just going to keep I wanted to practice one more. Make sure you've got it here. So when we're in class on Wednesday, you can ask questions if you don't quite got it. All right, so this problem, there's not a y in it, so the y is already 0. But we need to get all the terms on the left-hand side together. So we need to subtract the 2x and subtract the 30 first. So we end up with 4x squared minus 2x minus 30 equals 0, right? And now I'm looking at this and saying, what is a quadratic trinomial? But I see a GCF, so I'm going to take it out because I know by taking the GCF out, I'm going to make the math easier. So I'm going to divide out of 2 from all of these. And so now I have 2 out front times 2x squared minus 1x minus 15. Right, so here we are. Now the inside part is what we're going to worry about factoring. I'm not going to worry about the 2 out front. We took the 2 out front. That's just going to make everything easier for us. This next part, I'm going to box that minus 1x. 2 times negative 15 is negative 30. All right, so negative 30 is what we're going to use for our factor pairs. So negative 30 over here is 1 times 30, 2 times 15, 3 times 10, and 5 times 6. We did 30 up above. This time it's negative. So this means that we're going to subtract, right? Signs have to be different because it is a negative 30. And we're going to subtract to negative 1x. So we're going to use the 5 and the 6 again, like we used up above. It needs to be a negative 1x, so that means the 6 is going to be my negative factor. So I'm going to take this 2 is going to hang out front. Let's try this again. 2 gets to hang out front here, and then in parentheses we have 2x squared plus 5x minus 6x minus 15. Right? Now, draw my wall right down the middle. So right now, the 2 out front, this guy here, we just get to ignore him. Remember, we don't even care about him. We don't care about him when we go to factor at the end. What I'm going to do now is I just need to factor what's in the parentheses. Keep going. So here, I have an x. I can divide out of both of those. So I have x out front times 2x plus 5. Over on this side, the only thing they have in common is really 1, but there's a negative in front of that 6, so we're going to divide out a negative 1. So this is negative 1. Something's not right. Oh, because I didn't put the 15 here. That's what I didn't do, right? Let's fix this. That should be 15. It should be oh, it is minus 15. I just can't read my writing. This says minus 15. Got a little sloppy. Sorry about that. So when you divide out your 1, negative 1, then I have which means negative 1 is not my factor in that case. That means I can divide out a negative 3. Right, so this is negative 3 out front. Negative 6 divided by negative 3 is 2 times x. Negative 15 divided by negative 3 is positive 5. I knew I had a mistake because I knew I needed to get to 2x plus 5, and something didn't seem right. So my bad penmanship almost caused me to mess up this problem. So now we have 2x plus 5 times x minus 3. Technically, there's a time of 2 out front equals 0, but we get to ignore that 2 out front. Right, all I care about is solving for x's, so I'm going to take that 2x plus 5 and set it equal to 0 and solve for x. So subtract 5 from both sides. 2x equals negative 5 divided by 2. X equals negative 5 over 2. And then we'll do the other side. X minus 3 equals 0. Add 3 to both sides. X equals 3. So my answer is x equals negative 5/2 and 3. There we go. So that is solving by factoring. I kind of gave you lots of examples in these notes, especially since we're not together in class doing these. I just want to make sure you got some good practice with me before you go working on your homework and seeing if you can do it yourself. All right, we'll see you next for solving by quadratic formula in our next set of notes.